Hi, I'm Lester Martin, a developer advocate here at Datavolo. I want to take a few minutes of your time and really make sure we have a conceptual understanding of what a RAG AI application is and what the data pipelines that fuel such applications might look like. RAG stands for Retrieval Augmented Generation. Okay, so you can probably start to think we need to retrieve some information, augment it, and do something else. Let's think about what we're augmenting first. And what we're going to augment is a concept called an LLM, a large language model. What is this really? It's really just an AI app. Well, heck, think of Chat GTP. Think of those conversational AI bots that you're out there, and those are powered by large language models. What these things have really done, and they really just have been trained by looking at information that's out there, a lot of text that exists across the internet. And what the system had to do to work well, it simply had to say, well, the world is too much, so let's look for smaller and smaller elements. So maybe take a book, for an example. We had to break that book down into chapters, and chapters have paragraphs and such. And those might be a concept that we use, might be the level of granularity that we use for a concept that the engines had to do called chunking, breaking apart, creating sizable chunks that provide context, but aren't too computational heavy and don't cost more or less than we have to. And that's really what these AI engineers have been doing in the background, training, building these models so they really work as well as we all want them to be. So chunking, keep that in mind. We're going to talk about chunks here in a little bit when we talk about the data pipeline of all this. What's another thing? Well, with those chunks, those paragraphs, for example, these computers don't really understand English or Spanish or some other language. So what they end up doing is taking those chunks, basically text data in most cases, and create a mathematical model of that. We can get into the data science and the math and everything. I'm not going to go there. We're just going to call them embeddings, multi-dimensional representations of a chunk of data. And then what do we do? Those systems ultimately have those things stored all over the place in the background. All right, so I want you to hear those phrases. They're really important to us, and they'll matter in a minute when we get into the RAG application itself. All right, so RAG applications again, retrieval augmented generation. What this is really used for is think of your organization. The concern with taking a base large language model or a base kind of a chat engine and just put it on the internet and driving maybe your chat channels or other decision-making processes with humans on the other side is, what do you do with all that internal proprietary information? In general, you don't want to bring that to the large language models, and it becomes often a lot of people's or has some privacy issues. And even more important than that, it costs a lot of money and a lot of time and a lot of resources to train these models. So every company is not going to have their own large language models. You're going to see a few giant companies do this, but for the most part, most of us can't afford to do something like that. So what's going to happen is the system's going to get a request, a prompt or a query or something. Hey, find me out this and that and that and this. So a custom solution or maybe a framework. There's companies out there, we have partnered with some as well. They're going to take that information and they're going to say, look, I can't just take that prompt and go to the large language model. I need to go and get some contextual information, some additional information that aligns with your request. And how do they do that? Well, they take the text that you wrote, they turn that, it probably itself is already pretty small. It's probably a chunk size of information. And just like we talked about a minute ago, it's going to make an embedding, a mathematical representation of that. So if we can take that and go look somewhere for similar, let the engine sort out similar representations, then we have some additional information. Those similar informations are going to be stored in a concept we call a vector database. So a vector database has all these previously calculated, recorded bits, and you're going to see in our pipeline where they come from your own business documents, etc., that you have. But a person comes in, they write what they would like to do. We take that, make a computer version of it, ask this vector database, is there some text, some additional information that's useful, that aligns, that's very relatable to that? We retrieve that, and then we augment the original request. Hey, find out this, that, and the other. What we'll basically say, given this, and we'll present all that additional information, and then we'll supply the kind of the original request that says, okay, and then we can hand that to a large language model. Those systems allow that today. You know, if you've been playing around with Chat GTP, you know that as well. All right, so the good news is after that, that's it. You know, we find the information, we supply it, we send it on. And I said, that's it. That's hard stuff to do. People are working very hard to do that well, etc. But there really is some additional elements here that we have to kind of consider because this is still early days for a lot of folks in this space. This way to take your company's data, your enterprise, your organization's data, and bring it to this into this AI space to be retrieved and augmented to the standard large language models really means we need to build a custom data pipeline, or a data pipeline at least that's aware of the kind of information that we have. So in that pipeline, while there's a big talk about ETL versus ELT, in this space, the classical extract, load, and transform pattern really makes a whole lot of sense. And I'm just going to run you through some of those elements. So for extraction, pretty straightforward. We need to be able to target, you know, some bulk of information, some data lake, some repository, S3, Google Drive, SharePoint, something like that, and say, you know, what to look for. That could be targeted based on groups, folders, types of documents, etc. And we want that retrieval to be pretty bright. We want to introduce, you know, and keep alive those kind of change data capture, CDC style patterns. If you're not familiar with CDC, what we're really saying is, in addition to pulling documents that we've never seen before, let's look for documents that might have changed since last time. Something might have changed that we want to also bake into this pipeline. Why? So our front-end RAG applications will go really well. So we're going to retrieve that information. You know, the first big step of that is, just like I said, a computer doesn't really understand English. Well, it sure doesn't understand, let's just take a PDF with lots of text, maybe windows with or little sections with graphics, or table, you know, tabular data with some, you know, maybe some financials and all that kind of good stuff. So what we're going to do is we're really going to do a concept we call parsing. We're going to turn that document into a JSON representation. So we're going to use a concept called computer vision, meaning just like you and I look at a document, we say, there's the header, there's the title, there's the author, there's the summary, there's a, you know, visual representation of what we're talking about. We're going to do that same thing. We're going to visualize, let the computer visualize what it sees and think like a human about chunking of things. And from there, we can do some additional transformations. You know, the good news is the tech stuff, we're probably in good shape for a second, so we can kind of leave that alone. And we can look at the other stuff, the tables, the images for good examples. And they're going to be specialized AI products, often LLMs themselves, that we can say, hey, taking this graphic, give me a summary. Tell me what's going on here. Taking this table of data, you know, provide me back some facts that I can use. So we're going to take that, convert it back to text representations of things, inject that into that JSON graph that represents our document. And we can even go further. We can even augment, just like, you know, enrichment. We can go out there and say, well, I know I'm doing roughly this kind of information. I saw this value. Maybe we're an automotive system or something. Maybe we're looking at automotive maintenance, service maintenance documents, you know, service reports at the end. Maybe there's a VIN in there. Maybe we augment on something like that. We, you know, ping a database and find out the make, model, and year. So we can enrich and clean and standardize. So what do we have now? We got this big JSON document, big or small, depending on the source document. And we have a problem, just like the internet has a problem. That's a lot of information to kind of summarize, or not summarize, to build a mathematical model that more specific questions can find. So we have to go through that process of chunking that I kind of suggested earlier. So we're going to use, at least naturally, those breaks and those categorizations that we saw in the document to kind of help doing that. And then we have a couple other rules, not too big, not too small, all that stuff. And usually we call this the Goldilocking, you know, finding that just right size for chunking. And sometimes we spend a little time not just doing this, but making sure it fits in nicely with the RAG application. All right, after chunking, we're really that, you know, we got through our E and our L, and we're really kind of getting toward the E and the T, extract and transform. We're really rushing toward the loading. So we need to ultimately load this information in a vector database. If you remember in that RAG app, the request comes in, we turn that request into some kind of mathematical representation, an embedding. We look in this vector database for other embeddings that are similar to that. Well, here's where we're going to load those. So at this point, we have these clean, enriched, normalized segments, chunks. And we're going to take those chunks and then create those embeddings and store those embeddings in that vector database so we can use them in our front end. And to be honest, you're kind of at the end of the loop here. At this point, you're just going to run this ETL process either continuously, periodically, whatever is the most appropriate. And you built a pipeline top to bottom, as you see in that image right there. The good news is you put it all together. You have a solution. Really allows us, as folks are working on that RAG application, they learn new ideas and then learn new strategies and standards. We can go back and what you want to do is have implemented that ETL pipeline and some kind of tool that really does provide you, flexibility and productivity, of course. Hopefully a tool that you can use like Datavolo, a low-code visual model that also allows you to build custom code with Python and Java, of course, but something that's templatable, that has a whole bunch of opportunities, because not only do we need to be flexible about fine-tuning things, we need to be able to be adaptable and flexible when we change segmentation approaches, when we change the vector database, when we change the behind the scenes LLM that we use to convert images. We need to have a lot of those options available because that's really where we need to specialize and customize in our data flow, not steps in the general flow. We want a template to help us get there that'll actually solve a lot of folks' problems and then allow lots of what about this, try that, and some way to do that much faster. So again, I'm obviously advocating, I didn't show you any bit of the tool today, but I'm advocating and come and take a hard look at us with Datavolo. Our whole mission really here is to make you, 10 times more productive, building these data engineering pipelines that are going to fuel those AI applications. So again, Lester Martin, Dev Advocate, come let us know how we can help you out.